Chapter 22, Water Pollution. The second part and last part is going to start out with a little case study, arsenic and drinking water. What we're finding even across the United States is lots of drinking water has this chemical in it, and of course it's a toxin, it's a poison to us. It comes from things like paint and other industrial products carry it. The problem with it is long-term exposure can lead to skin, lung, and bladder cancer. Couple treatments they have for it, actually not real great ones, but one of them is actually nanoparticles of rust, believe it or not. So they would actually put that in the water, and what happens is it pulls that arsenic out. It actually attaches to that rust, and then you have to take the rust out. So it's not an easy process. Kind of all goes back to the idea that let's in the first place. A couple ways to purify drinking water, and of course, again, in the United States, we have very good drinking water. Reservoirs, of course, purification plants. Reservoirs are like behind dams, and we can withdraw from that. There's purification plants pretty much in every city in the United States, and small regions like northern Wisconsin, of course, they may share some. But what happens is they chlorinate the water. They clean the water of all little bugs and bacteria and things like that so we can drink it. We could process sewer water into drinking water, too. Believe it or not, the waste treatment plant, where when you flush your toilet or take a shower, all that water and everything goes to the Brookfield waste water treatment plant or the Milwaukee one. And what happens is by the time they process it, the water that comes out that they re-release into the Fox River or into Lake Michigan is actually clean. You can drink it. Not that we do, but we could. Expose clear bottle plastic containers to sunlight and UV. This is used more in third world countries where you can actually use the sunlight in order to kill those bugs before you drink it so you don't get sick. Life straw is an idea of, again, in third world countries where they don't have clean water. As you drink through a straw, that takes all those contaminants out. PUR, or PUR, is actually a means at cleaning things using chlorine and iron sulfate powder, and what that does is, again, pulls toxins out in third world countries if we can just get them the supplies. Is bottled water a good option? Bottled water, of course, became very popular in the 2000s. It can be useful, but it's very expensive. It's deemed about 1,000 times more expensive than just turning on your tap. And quite honestly, since the United States has some of the world's cleanest drinking water, what's coming out of your tap generally is more regulated than what's in that bottle. So use of bottled water can create environmental problems too, because it's withdrawing. In the movie Tapped, which hopefully we'll get to see, what happens is in a little town in eastern part of the United States, Nestle comes in and withdraws their groundwater, and they see their water table just drop. So is it a good thing to transport that water all the way from the East Coast to the West Coast, for example? Really, should that be legal in basins? Couple laws. First of all, the Clean Water Act came out in 1972, but the U.S. Safe Drinking Water Act came out in 1974, which kind of paralleled or piggybacked on that Clean Water Act. It sets the maximum contaminant levels for any pollutants that affect human health. So it really sets very high standards, and keep in mind that at these purification plants for the water we're drinking, they have to test their water multiple times a day to make sure it's okay. Of course, in Milwaukee, the cryptosporidium in the early 90s kind of slipped past them somehow, but that actually strengthened the laws even more. Health scientists, obviously, they want to strengthen the law even more. Water polluting companies want to weaken the law. Ocean pollution, a terrible problem. Again, it's one of those things that's deemed vast in that we can just throw anything in there. A couple laws are key to this, too. Most ocean pollution originates on land, includes things like oil and other toxic chemicals. So again, those little oil drops that you have from your car, when it rains, gets flushed out into the ocean. Solid waste, again, until the early 80s, I believe it was, New York City used to take all their garbage, put it on a big barge, and dump it out about 2 miles out, and then, of course, all that garbage would come back in. And I'll show you some pictures of some nasty stuff, too. Key to protecting the oceans, reduce the flow of pollution from land and air and from streams emptying into the ocean. There was a very key law in 1972 called the London Dumping Act, which kind of focused a little bit more on Europe, and it really prevented them from dumping things like raw sewage and garbage in oceans, although some nations still do it. Municipal sewage from less developed countries, of course, are often dumped into the ocean, particularly around the Mediterranean region, and of course other regions too, more third world-ish, where they just don't have the treatment facilities like we have in the United States. Deeper ocean waters, of course, what can happen is some of these pollutants can get diluted, some get dispersed, as I'll show you in a second, and some degradation or breaking down does occur great enough. In the U.S. coastal waters, we know that if raw sewage is put in, of course, that's going to transmit viruses. It could transmit bacteria, too. Sewage and agricultural runoff, nitrates and phosphates, of course, cause eutrophication, which cause those harmful algal blooms, and of course, we get those called hypoxia zones. So just a little diagram here of some things that can get into the oceans. We have anything from nitrogen oxides from autos, smokestacks, other heavy metals that actually can go right from industry and flow into these estuary streams, or streams that lead into estuaries, and of course become toxic. Urban sprawl, what happens is bacteria and virus from sewers and septic tanks contaminate shellfish beds and closed beaches. That actually happens in Milwaukee. Oftentimes in Milwaukee, what will happen when the MMSD has to release their sewage because we have a heavy rainfall in the deep tunnels, what happens is Bradford Beach actually gets closed, and actually it goes all the way down to Chicago too, because raw sewage actually gets put into Lake Michigan. Construction sites can be bad too. Those sediments can be washed right off into the ocean. Runoff from farms of pesticides, manure, fertilizer, obviously. Excess nitrogen, phosphorus toxins. We can get red tides, which are when excessive nitrogen causes explosive growth of toxic microscopic algae, poisoning fish and marine mammals. Healthy zone, of course, there is some healthy zone out further in the ocean, but we want to get that throughout the entire ocean where things can actually live and those nice little plants and animals can actually live. Oxygen depleted zone, so the hypoxia zone, like I talked about in the first lecture, the Gulf of Mexico is a dead zone. And some other toxic sediments, of course, can contaminate shellfish beds. You know, the reality is we like to eat shellfish, everything from oysters to clams to even lobster and crabs included in that kind of thing too. And you know, what happens is those heavy metals get down there and they're getting contaminated with, and that's bad. Open garbage patches, terrible. There's something called the North Pacific Garbage Patch, which is, so these garbage patches are rotating jars on or beneath the ocean surface or the water surface. A lot of plastic pieces that are harmful to wildlife. You've probably seen pictures before of like sea turtles or birds caught up in the six-pack rings. You should break those up before you dispose of them in case they do end up in the ocean, which sounds silly because of where we are here, but you never know. There's really no practical little graphic of it. I know it's hard to see, but take a look at where the United States is on the right side. And because of the swirling currents, what happens is we get these massive amounts of, and you can see right here, garbage right here. And those are probably dead zones, and those are probably areas of animal life. So what about from oil? We know crude and refined petroleum. Crude petroleum is that which is not processed yet. It's that thick, gloopy stuff that comes right out of the ground. Refined petroleum is like gas, diesel, fuel. So it's gone through the refinery process. That really is a disruptive pollutant. The largest source of ocean pollution is, of course, urban and industrial runoff, as I said before. A couple case studies, 1989, the Exxon Valdez, of course, crashed up in Alaska. They're still seeing ramifications of that. 2010, of course, we had the BP Deepwater Horizon in the Gulf of Mexico. Other things that can end up in the ocean are something called VOCs, or volatile organic hydrocarbons. They kill many aquatic organisms. Think of anything that really can explode for that matter, and that's why it's called volatile, even like gases and spray paints and things like that. We get these tar-like globs on the ocean surface from the BP oil spill and other oil spills. The problem is they coat animals, and of course then those animals can't fly anywhere, and they die. If they can't fly, they can't survive. They can't eat, can't get away from predators. Some heavy oil does sink, and then what happens, and we're seeing this still on the Gulf shores of Alabama, where it sinks from the BP Deep Horizon, and then what happens is it affects the bottom dwellers, plus it actually comes up later. A couple of things that actually to note about oil, of course, we get faster recovery in warm water with rapid currents because those currents can move it on, and hopefully the warm temperatures actually promote more bacterial growth so we can destroy those bad oil spills. In cold, calm waters, recovery can take decades and decades, and of course that's what you see up in the Exxon Valdez. A couple methods to prevent oil spills in the United States. It is now required that the oil tankers have double hulls if they're in our waters within our 200 miles. And the reason is because if they hit something, we have a hull within a hull system, and it doesn't necessarily spill the oil out. What's really helped is the Oil Pollution Act of 1990, and that's kind of led to that double hull idea. You can see a picture here of the Deep Horizon oil spill, and what happened is, of course, one of the junctures or the joints down below actually broke, and it spilled oil everywhere, and of course we had a big explosion. And just to expand on that a little bit further, what happened was it was a mile deep where the oil started leaking out, and it actually released, I think it leaked for 87 or 89 days total. So we had pure crude oil coming out. About 4.9 million barrels of crude oil came out. It contaminated vast areas of the coastline, and it's still doing that too, caused by equipment failure and poor decisions. The government, of course, developed new standards for offshore drilling procedures after that. Reducing water pollution requires that we obviously preventing it in the first place. We don't want it in the environment. We don't want it out there because it's so hard for our environment to break it down. It's not natural. Work with nature to treat sewage. It's kind of the idea that like a wetland is actually great at getting pollutants out. So we kind of mimic that actually idea of a wetland when we do a lot of wastewater treatment, which is a great idea. Use natural resources far more efficiently. Again, back to the prevention model. Reduce flow of pollution from land, obviously control our land use. If you ever notice a new building going up, even a house, what they have to do is put this like fence around it, this little black fence, which is about 2 feet high. And what that does is it's required by law so we don't get things blown away from there. Hopefully it catches it. And then obviously not end up in our waterways. Air pollution obviously is another problem we'll hit down the road. And of course it's linked to energy and climate policy too. So coastal water pollution prevention, here are a couple things. Again, just a graphic of all the separate sewage and stormwater lines. That's a huge problem right now in Brookfield and in Milwaukee. When it rains out, that rain goes into our sewage system, and then what happens is that has to be processed too. Technically, it really shouldn't have to, but what happens is it's nice to have processed. It is nice that stormwater is treated because, again, if it has oil or any other contaminants in it, it's treated before it gets released in the environment. The problem is it's very costly. Requires secondary treatment of coastal sewage. We'll talk about that in a bit. Use wetlands and other natural methods to treat sewage. The problem is we have so many people, the wetlands could never keep up. Ban dumping of waste and sewage by ships in coastal waters. Strictly regulate coastal developments. Require double-hulled tankers. We're there. Cleanup. Improve oil spill cleanup capacities. You know, there's bacteria that actually can destroy that oil now and eat it. The problem is it works so slow. We can use nanoparticles on sewage and oil spills to dissolve the oil or sewage. The problem is that's still underdeveloped right there yet. Surface water pollution from non-point sources, so we don't know exactly where it's coming from. Agriculture, the thing is we need to reduce erosion, which we talked about in the past, and because with erosion what happens is then all those sediments just run off because vegetation does not contain it. Reduce the amount of fertilizers, buffer zones of vegetation, even like agriculture, organic farming techniques, way better because we don't use those pesticides in the first place. Implement the IPM program so we use pesticides prudently. Institute tougher pollution regulations for livestock. Times that livestock waste runs right off into our waterways. Of course, the key things, 1972 we had the Clean Water Act, which really cleaned up our environment and really helped our surface waters particularly stay clean. And then 1987 we had an addendum to that, which is the Water Quality Act that gave even stricter guidelines to what can be discharged into our environment. So what are some achievements of the Clean Water Act? Well, quite honestly, the United States has probably the cleanest water in the world. We can't just discharge things and from factories. We really limit it, and then it doesn't contaminate our environment. Septic tanks. Septic tanks are basically holding systems, and I'll show you a picture of that in a second. It's actually something I have at home. If you live in a rural area, you probably have a septic tank also. There's also wastewater sewage treatment plants. Again, the Brookfield one is where most of you are gonna, when you flush the toilet, when you take a shower, when you run the sink water, anything like that, it's gonna go there. When it rains, everything goes there and it's processed it's cleaned, and what happens is then it's returned to the Fox River clean. So we treat it, we take all the bad stuff out. There's really two stages that the Brookfield uses. There's a primary and a secondary. The primary sewage treatment is a physical process. So what they do is like if you can imagine it raining and sticks get into our drainage system. So what happens is they have to take those sticks out. Anything you throw down the toilet has to be taken out. Things as extreme as little kids' toys and condoms and things of that nature get thrown down the toilet. What happens? That needs to be taken out. So that's the physical process. The secondary process is more bacterial. What they do is they use a biological process and kind of mimic nature where they have all these feces and everything like that. In order to break it down, they let bacteria destroy it, and it works great. And then what happens is we get a dry sludge out of it, and that sludge can actually then be used as fertilizer, and it's brought to a lot of farms just out west of here. Tertiary or advanced sewage treatment, not all sewage treatment plants have this. It's a special filtering process before, and Brookfield does have this, before the water is returned to Fox River, they actually chlorinate it to kill all the bugs and everything. So it really is drinkable. But the problem is we can't just add chlorine into the environment. So what they have to do is then take the chlorine out. Other ways of doing tertiary is actually using UV rays to kill all that bacteria. Many cities, of course, violate federal standards for sewage treatment plants. Federal law does require primary and secondary. A lot of times there's exemptions from the secondary treatment, so we're putting that raw sewage into our environment, and of course that promotes bacteria and viral spreading, and of course there's health risks of swimming in water that's blended with sewage. Disgusting. This is a septic system, so this is something like I have at my house. What happens is any water that leaves the house, any solid waste that leaves the house, goes into this, goes into this big tank like that. And what happens is all the heavy stuff sinks to the bottom, and the water actually goes out to what's called the drain field. And trust me, in my yard, the grass grows really well there because it's constantly getting watered. So that water just kind of goes out. So any urine or any shower water or anything like that just goes right out to there. So it's not wasted. It's kind of almost like gray water system. Then what happens is once a year I have that magical truck come and they pump that sewage out, and they actually bring it to a local sewage treatment plant that actually processes it, it's returned to the environment. This is kind of the premise of how a sewage treatment plant works. If you take a look at it, there's two steps. There's primary and there's secondary. The primary one, as I said, they physically take out the big stuff. So what they do is have a bar screen right here, and any big stuff, sticks and things like that, anything you throw down the toilet, like toilet paper and stuff like that, gets caught there. Then what happens is we have what's called a grit chamber. So all that heavy stuff sinks. Then it's going to go down to a settling tank, which are absolutely huge. And with that, what happens is it goes into the secondary process. In the secondary process, they have an aeration tank. The reason it's aeration tank is because they add aerobic bacteria. And that aerobic bacteria is going to start destroying this. And it's going to break that fecal matter down, and then we get what's called a dry sludge, and that can actually be put on cropland, pasture land, rangeland. So that's actually taken out to farmers' fields, and they use it as fertilizer. Expand on that class a little bit too. So can we improve on conventional sewage treatment? We can remove toxic waste before water goes to municipal sewage treatment plant. It helps the sewage treatment plant process. Reduce or eliminate use and waste of toxic chemicals. Use composting toilet systems. Wetland-based sewage treatment systems, we'll talk about that. So how can we prevent water pollution? In developed countries, bottom-up political pressure to pass laws. Of course, that's like us. Developing countries, little has really been done. China, of course. China, actually, their river systems, and India, too, the river systems are terribly polluted. And very common for people to be drinking out of the water that they're also washing their clothes into, or their feces are going into from their septic systems. How can we avoid producing water pollutants in the prevention method? Here's some water pollution solutions. Prevent groundwater contamination, reduce non-point runoff, work with nature to treat sewage and reused treatment water, find substitute for toxic pollutants, practice the 4 R's of resource use, refuse, reduce, reuse, and recycle. We'll hit that later. Reduce air pollution, reduce poverty, and of course slow population. So what can you do? Fertilize your garden and yard plants with manure or compost instead of commercial inorganic fertilizers. Use Milorganite. Minimize use of pesticides, especially in your bodies of water. Prevent yard waste from entering storm drains because that will contaminate too with the pesticides and fertilizers it has on it. Do not use water fresheners in toilets. Some of you do that where your water turns magically blue. Do not flush unwanted medicines down the toilet because our wastewater treatment plant does not have the capacity to take that out. So then we get those drugs into our groundwater. Do not pour pesticides, plant solvents, oil, antifreeze, or other harmful chemicals down the drain. So here are the big ideas. A number of ways to purify drinking water, but the most effective and least costly is prevention in the first place. The key to protecting the oceans is to reduce the flow of pollution from land and air. And reducing water pollution requires that we prevent it, work with nature, and use natural resources efficiently. We do get these dead zones. They disrupt ecological interactions. We can use solar energy to purify water and reduce waste. That sun gets really hot, especially if we have a focal point. And we can use natural nutrient cycles to purify water. That's it for chapter 22.